All right, guys, ready for a really cool technique?
No.
Write this down. You're gonna really want this down. It's a cool technique.
My pencil is ready.
Now, what's cool about this technique, what we're gonna do is you guys can look at this and you say, all right, this looks like pretty difficult to be factoring, right? And what I want to show you is just a technique that you can use to solve problems when they're difficult, when they look like they're going to be difficult by factoring, or even solving by what we call like substitution. So what I'm going to do is I automatically look at this and I say, well, if I said, you know, x squared plus 2x plus 1, right? Just kind of forgot about my exponents, but just looked at what were the coefficients of, you know, instead of really like my tan and my 2 tan, if I just kind of look at this, x squared plus 2x plus 1, and if you're just going to, if I just said, hey, ladies and gentlemen, why don't you see if you can factor this? Well, you might say, well, that's not too bad, right? X plus 1 times x plus 1, correct? So what I'm looking at, and that's kind of the same thing, but you're saying, well, we have a fourth and a squared. Well, really, ladies and gentlemen, even if I gave you something like this, you guys still should be able to change this factoring technique to x squared plus 1 times x squared plus 1, right? Because x squared times x squared is going to give you x to the fourth. When you multiply those, you're going to get 2x squared, and 1 times 1 is going to give you 1. Does everybody see that? So really the exponents you can see are just changed, but they're not going to change actually the problem. The difference is we like dealing with the x's. You guys are used to that. You have a lot of practice. Rather than using x's though, we're now using tangents of x. So it looks a little difficult. But really guys, the math is exactly the same. So what I would tell you to do is just have, let's just say x squared equals tangent 4 to the x, and x equals tangent squared to the x. So what happens when you guys look at this, when I have, when I plug that in, like I said, when I factor this, I get x squared plus 2x plus 1 for my x squared is tangent fourth, you know, and x equals tangent squared of the x. Well, now when I factor that, I get x plus 1 times x plus 1, which is really x plus 1 squared. What I get then is tangent squared of x plus 1 times tangent squared of x plus 1. Right? Does everybody see what I did? All I'm doing is I'm just plugging them back in. If this is, when I factor this and I get, like I said, I don't, rather than writing it as tangents, I rather write it as an x squared and an x. So when I do that, I factor it out, and my answer, I get, Maria, is x plus 1 times x plus 1. Then I just plug back in what I was substituting in for my answer is tangent squared plus 1.
That's what x squared plus 1, x squared. Not x plus 1.
Okay. What I was saying, no. I was just rewriting, I was showing you guys this, x squared plus 1. I'll erase this. I was writing the x squared plus 2x plus 1. You can, let me just erase it. All I was doing was showing you that, was it doesn't matter if it's to the fourth and squared and 1, you're still going to get the exact same factor. You're still going to be able to factor it exactly the same. But in my substitution of my problem, all I was saying is I want tangent of 4 to the x to equal x squared. Do you see how I just substitute that in? I'm just saying I want that to equal that. And then I say, well, and then I want tangent squared of x to equal x. Okay? You could, like I said, if I wanted to use that, you could say, let's have x to the fourth and x squared to do that.
Well, it's got to be because tangent squared.
It doesn't have to be. You can make it equal whatever. But if you want it, all right, if you want it to be x to the fourth and x squared, then you'd have x to the fourth plus 2x squared plus 1, which I showed you before, which gives you x squared plus 1 times x squared plus 1, which, fine. You're still going to get the exact same answer. X squared equals tangent squared of x. So you're still going to get this binomial back. Does that make sense? It doesn't matter what you want to substitute it in for. You can substitute in for x to the fourth x squared, which is right here, or you can substitute in for x squared and x. It doesn't matter. The factoring is exactly the same. Yes? Okay. So that's just getting you through the factoring part of it. Now we have tangent squared of x plus 1 times tangent squared of x plus 1. I could go ahead and FOIL this out, but before I go and FOIL it out, I notice I have a tangent squared. I can rewrite a tangent squared as something, right? What do you say?
It's a secant.
Yeah, it's a secant. Secant squared of x times secant squared of x. Well, secant squared of x times secant squared of x is going to be secant to the fourth of x.
So tangent squared and secant squared equal the same thing?
No, tangent squared plus 1 equals
Oh.
secant squared. Yes?
Um,
Let me just turn this off real quick.